Hello everyone. So in this video we are just gonna extend our discussion over this topic, and we will just understand and learn how to use the sklearn inbuilt implementation of decision trees. So it is gonna be a small video. So let us just start. So decision tree from sklearn basically. So in the next video we will understand all the math behind decision trees, whatever we have learned, how to apply those with our own code. So with our own implementation, how do we do that? So it is basically a project on which we will talk about in the next video. So in this video we are just importing the libraries and just using something known as decision tree classifier. So from sklearn.datasets, so we would first import the datasets, and then from sklearn.tree we would import something known as decision tree classifier, and obviously the train test split we all require of every time. So first we load the iris dataset. So it is the datasets.load iris. In this way we have just loaded our iris dataset. Also we can see its description as I have explained in my earlier videos. But now what is important is this train test split, which will give us 4 matrices, and iris.data is basically all the x values, and iris.target is basically the result or the y values. So this iris.target will get split into y train y test, and iris.data will get split into x train and x test. And when nothing is mentioned, we will take the ratio to be 75%. So data will be like our train will be 75% and test will be 25% of the total data sets. So we build an object oriented classifier. So basically this is a classifier object handle basically, which is the decision tree classifier, and we fit our model directly, that is our training values, into this decision tree classifier object. And also then we call predict function on our both training dataset and testing dataset to see what are our actual accuracies over the training values and the testing values, to see whether our dataset can our machine learning model can perform well on the testing dataset also. So from sklearn.matrices we import confusion matrix. So this confusion matrix I have discussed it earlier also. So basically along the rows are the true values and along the columns are the predicted values. So I am basically saying that I have 3 classes, class A, B, C. In this iris dataset, you know that these classes are iris setosa, iris virginica, and iris versicolor basically, or whatever they are in order. You can check that out. So what we are saying is, in this true value, there are 39 true values of class A, out of which the entire 39 are correctly predicted. So the column represents the prediction, and again there is no inaccuracy in the second as well as the third classes. All of the true values are correctly predicted also. And similarly, but in this when we call over this y test values, we find that there are some inaccuracies. So that is not too much undesirable, because the inaccuracy is quite less, and a less amount of inaccuracy is actually desirable in order to prevent overfitting of our model. So what does this say? The second row of here, there are 14 true values. Actually there are 15 true values of class B, out of which 14 are predicted correctly and 1 is predicted as class C, but it is actually class B. Similarly, there are 12 true values of class C, out of which 11 are predicted correctly and 1 is predicted as class B, although it is class C. And now from sklearn.tree we just import export Graphviz. So what we are going to do basically is we are going to we are going to see what is our uh, actual decision tree looks like. We got some accuracy, so we are getting a very high accuracy on the training dataset, a little bit low accuracy on the testing dataset, but it is quite desirable. So we just want to see that what has our machine learning model done, how has it created the decision tree, how does the decision tree look like. So we will try to export that in a PDF basically. So from sklearn.tree we import something known as export Graphviz, and we also require Pydotplus, this library, so you should install this, pip install Pydotplus. So you can update pip if you want. So we import Pydotplus, and we from through export Graphviz we create something known as dot data. So what this dot data basically does is that it takes the object handle classifier, which is nothing but the decision tree classifier, and out file it takes as none. Then this Pydotplus can produce the decision tree graph from this dot data. So from this dot the graph which basically the classifier has also the training and the testing values, because it is fit with clf.fit we did. So the dot data basically takes those values, and this Pydotplus takes the dot data and create our graph. And this graph is written using the write PDF function. And if you just do iris tree.pdf, so you can see it has been. So actually you have to install Graphviz also separately. So I did not remove this error in order to show you this is the error which I first faced, so many of you may also face. So I did not remove this error from my slide, so that you understand that you also need to import Graphviz, basically install Graphviz in order to make this write PDF function work. So you can just do this, and our PDF file will be saved as iristree.pdf in the same current working directory as you are working in your VS Code. So now we'll get the iristree.pdf saved in the same working directory. So it will look basically something like this, and you can see all the parameters also here, the petal length. So for our first accurate split, the most accurate split which is selected by our machine learning model is the petal length, and this 2.45 is the most accurate value, and it is leading to a Gini index of, or Gini impurity of 0.66. So these all things I have clearly explained in our previous video what is Gini impurity. So basically if our class is completely pure, then our Gini index will be 0, and it is basically a measurement of how much pure or impure our class is. So these things have been clearly explained in our earlier videos. So in the next video we will just continue with our math behind this decision tree, and we will also understand what exactly went inside this computer algorithm to just create this decision tree. What exactly, all the math did the computer do so to create this decision tree and give us a very accurate machine learning model. So what we will understand that in our next video. Till then, thanks a lot.